Welcome to lecture 19 of the course CS213 Object Oriented Programming of the Kohat University of Science and Technology. In this lecture we will talk about exceptions. We will have a look at exceptions and how to handle exceptions, handling multiple catch clauses, nested try, propagating an exception, and the concepts like finally, throw, throws, etc. The reading material can be found in chapter 11 of the reference book, and then there are tutorials that can be found online. Whenever we run a program or when we write programs, there are errors. Errors are bound to occur. Errors occur in software programs. The Java programming language uses exceptions for error handling, and we need to have a way to handle those errors. As a programmer, we are required to handle the errors in such a way that does not disrupt the running of our program or the flow of our program. And that is where we can use exception handling or error handling in Java. With exception handling, a program can continue executing rather than terminating after dealing with a problem. We have used exception handling earlier, maybe not in much detail, but in some of our programs. And the difference with the normal error handling is when an error occurs, our program is disrupted, our program stops running, it is terminated at the point where the error has occurred. What we can do is we can continue with our program by handling the error in a proper way using exception handling. And what it will do is it will improve our program's readability, reliability, and maintainability. Exception examples can be, for example, arithmetic exceptions, attempt to divide by 0. These are errors that may occur due to some numeric calculations or numbers. Array index out of bound exception, as the name suggests, you might use an index of an array that does not exist or is invalid. Null pointer exception, you might have faced this error earlier. It is an attempt to use an object reference that hasn't yet been assigned to an object, and we get this error quite often. File not found exception, when we try to read a file or something that is not there at the location that we have provided to our program, then this is the kind of error that might occur. We use exception handling to handle these errors properly without terminating our program abruptly, by guiding the user to somewhere appropriate or correcting our program properly. The Java runtime system will attempt to handle exception. If we do not use exception handling, what the Java runtime program does is it attempts to handle exception, that is the default exception handler, usually by displaying an error message and terminating the program. For example, what we have seen so far is that whenever we get an error anywhere in our program, Java handles that error by terminating the program and guides us to that error through a certain line. For example, in this line we have exception in thread main java.lang arithmetic exception divided by 0 at example 1.main. That is an example program. That can be any program. The idea is that it guides us towards that error, that we can correct the error or modify our program to handle that error. What is an exception? An exception is an event that occurs during the execution of a program that disrupts the normal flow of instructions during the execution of a program. An exception and an error is something that we do not expect in the normal flow of our program. That is an error, an exceptional value that we might face during the execution of our program. When an error occurs within a method, the method creates an exception object and hands it off to the runtime system. We call exceptions are thrown. The exception object contains information about the error, including its type and the state of the program when the error occurred. We'll look at examples where we'll see how we can use objects to handle the errors, and we use the exception class and the objects of the exception class to catch the errors and try to handle those errors. Information includes the name of the exception in a descriptive message that indicates the problem that has occurred, the method call stack. The call chain at the time it occurred represents the path of execution that led to the exception method by method. In our error message or the exception that we receive, we will get the name of the exception that has occurred and a complete stack of all the methods where the error has occurred. The method call stack, we will get the complete chain of where the method has occurred through our exception object. And this information of course will help us to debug the program. It will guide us towards the error where the error has occurred or the exception has occurred, and we can correct our program. To look at the hierarchy, we have an exception class and its subclasses represent exceptional situations that can occur in a Java program. We looked at some examples of exceptional situations. For example, the IO exception, the file not found error, arithmetic exception, null pointer exception. And these are the errors that can be caught and handled by the application. Class error, on the other hand, and its subclasses represent abnormal situations that happen in the JVM, the Java Virtual Machine, and these are the errors that are not recoverable. These will terminate our program. These can be serious errors like running out of memory when we do not have enough memory to run our program or to load a class. And these might be if infrequent as against to exceptions. This is the hierarchy. There is the throwable class, and exception is a subclass of the throwable class, and error is a subclass of the throwable class. Exception has its own subclasses. Runtime exception, IO exception, that is a file not found exception, and that runtime exception has arithmetic exception and null pointer exception. And the errors cannot be called by the application. For example, application cannot handle the memory out of bound exception, etc. When our system runs out of memory, we might not be able to solve that through our program. Applications usually cannot recover from errors. They are usually crashed. Handling exceptions. How do we handle the exceptions? When errors occur, your program ought to either return to a safe state and enable the user to execute other commands, or allow user to save all his work and terminate the program gracefully. As a developer or as a programmer, what should not happen to our program is to crash somewhere that is not comfortable for the user, or in a way that is not desired by the user. It should either return to a safe state and enable the user to execute other commands. In erroneous situation or exceptional situations, the program or the software should guide the user to a proper handling situation, or it should allow the user to save all his work and terminate the program gracefully. How can we do this? We can do this through exception handling. For example, after a method throws an exception, the runtime system attempts to find something to handle it. Now, if we have provided that something to the system, then it will follow that. Otherwise, it will do whatever it can by default. If the runtime system could not find an appropriate exception handler, as a programmer it is your responsibility to provide an appropriate way of handling the exception. Otherwise, the runtime system and consequently the program will terminate. When an appropriate handler is found, the runtime system passes the exception to the handler. An exception handler is considered appropriate if the type of the exception object thrown matches the type that can be handled by the handler. We have their own handlers or objects for the particular kinds of exceptions, the kinds we saw in our previous slide. We have each exception will have their own type of object to handle it. The exception handler chosen is set to catch the exception. We catch our exceptions through those exception handlers and guide the program towards a safe state. Let's look at a few examples where when we use no exception handler and what should happen. What should happen is the exception is caught by the default exception handling. The default Java exception handler catches the exception, that is the Java runtime system displays a string. As we have seen, we get an error in red color that is displays a string describing the exception and prints a stack trace from the point at which the exception occurred, and that line guides us towards the error where the error has occurred and allows us to correct it, and at the same time our program is terminated. You might have seen that whenever we get an error, our program is terminated along with a line telling us where the error has occurred. That is called the stack trace of the error. An example one where we are not using any exception handler. For example, we have a value that is equal to 0, and what we are trying to do is we are trying to divide a number on that value. Now if you have tried this thing in any other language, in C or C++ or maybe Java, here we are not able to divide a value by 0. You will get a divided by 0 error. Now our program, as you can see, is not handling this error. What should happen is whatever is there after this line, the line where the error is occurring, and we can see all the call stack trace over here. The program will stop over here, it will terminate, and the next line will not be executed. This will not be printed because the error has occurred, and it stops the program at the exact point where the error has occurred. Example 2, for example, there is another kind of an error that can occur. Let's say we have initialized an array that can take only one element. The size of the array is 1, but what we are trying to do is we are trying to assign 2 elements to the array. So if the size of the array is 1, we can do the assign one value, but if we try to access an index that is not there in the array, we might get an array index out of bound exception. Again, we are not handling this exception over here, and what should happen is our program should terminate right at this point without printing this line. So this line will not execute because we are not handling the exception, and our program terminates right at the point where the error has occurred. As we can see in this line, it is telling exactly about the error and then the point where the error has occurred. Now according to this error, the error has occurred in line 6 of the program example 2 in the main method, and this is the complete name of the error. In the second example, we use basic try catch block. The try block place the code that might cause the exception in a try block. For example, if we are trying to use a code where we can expect an error, for example the error where we can possibly have a divide by 0 situation, or we might run out of our index values in an array, or there are other situations. For example, we are trying to read a file and there might be a situation that the file not be found, then we write the code for those kind of task in a try block. Place the code that might cause the exception in a try block. As a programmer, you decide which code can possibly generate an error and what kind of an error can be generated. Then we put that code in a try block, and what happens is when error happens, Java ignores the rest of the code in the try block and jumps to the catch block. Try block is always followed by a catch block. The catch block is adjacent to the try block. Specify the exception. What we do in the catch block is we specify the exception that you wish to catch. For example, if you are suspecting that a certain error will be caused by the code, we try to add the exception for or catch the exception for that in the catch block, or catch the general exception. If we are not sure what error can be caught or we are trying to catch, then we can use the general exception, that is the exception class, that is the super class of all the types of exceptions that can be generated. Then we can generally use the exception class, that is the general class or the super class. Otherwise, if we do know specifically what kind of an error can occur, we can use the specific exception handlers. Since all exceptions are subclasses of the exception class, you can catch all exceptions using this way. Using the exception class, if you are not sure about the specificity of our exceptions, then we can use the exception class, that is the super class of all the exception classes, to catch that error. It will catch all the errors, and it may be, if you are trying to be on the safe side, we can use the exception class. Execute the code if the exception is thrown. What will happen now is that the code in the catch block will be executed if there is an exception in the try catch block. If there is no exception in the try block, the code in the catch block will be skipped and will go to the next point. Now, what should happen to the statements after the catch block? Previously, we saw that when an error occurred in our program, the whole program was terminated. Execute if either the exception is not thrown or if it is thrown. Now, in this situation, when we are handling the exception, the code after the catch block will be executed if there is or is not an error. Now, this is how exception handling is different from the default error handling of Java. For example, this is our try block, and what we do is we are trying to catch an exception. In this case, it is a general exception, therefore we are using the super class exception, and we will get the error or handle exception if there is an error in the try block. Otherwise, this catch block will not be executed. If there is no error in the try block, this code will not be executed. If there is an error in this try block, this code will be executed. But this code will be executed irrespective of the error in the try block, or even if the catch block is executed or not. That is how it is different from our previous slide where we were not using exception handling, and when an error occurred in this line, for example in the previous line, rest of the program was terminated. Try catch block, for example, if we look at an example, the same example where we now have a value 0 and we are trying to divide a number by that value, and this should not be printed. Now we can see that there is an error in our program and we are trying to catch that error. Now, as against our previous case, for example, here the error has occurred and the code will jump or the program will jump to the catch block. The point where it has encountered the error, it will jump to the catch block. Now it cannot, the try block will be, rest of the try block will not be executed, but it will not terminate our program. What the difference over here is from our previous case is where we are not using exception handling, that when the error is generated at this point, it will jump to the catch block, generate the error, display the information on the screen, whatever we are trying to display to the user on the screen, and go to the next line. So the program will continue to run, as opposed to the previous case where we are not using an exception handling. There the program stops executing. This will not be printed. This statement is never executed. In case of error, control jumps out of the try block to the catch block. The catch block catches all types of exceptions. Since we are using the general class, the super class, that is the exception class for catching our exception, that is why it will catch any type of exception that is there in the program. By catching the exception, it allows the program to continue executing. It will go ahead without any interruption and complete its execution. Example 4. For example, we have the same example, but now we are using an exception handler. Now in this case, we are using a specific exception handling for a handler. For example, if we are sure of the kind of error that we can get, and how can we be sure of that? Whenever we are trying to work with arrays, then we might have the idea that what possible errors can we get whenever we are using arrays. Then we can try to catch the possible errors or exceptions that can occur while handling or working with arrays. And one of those possible error is array index out of bounds exception. That is when we try to access the element of array or the index of array that is not there. For example, the size of our array is 1, but we are trying to store 2 elements in that array, which obviously will not be allowed by the program. But how do we handle this error? How do we handle this situation? Previously, when we were leaving the handling of the situation to the default exception handler of Java, that was terminating our program. In this case, we will get this error. This line will be printed, and then we will jump to this line. For example, we have occurred an error at this point. The program will jump to the catch block and execute whatever there is, and then jump to the next line, that is a print statement, and it will be executed. Now the things to note over here are this will not be printed. Of course, this line, the try block, whatever the rest of the try block is, will not be executed since the program has now jumped to the catch block. The catch block catches the array index out of bound exception. Now in our previous example, we were using the general class, that was the exception class. In this example, we are using the specific class, that is the array index out of bound exception class, because we are sure about the error that we might get from this code. That is why we can use a more specific exception handler rather than the general exception handler. Array index out of bounds exception, as we saw previously, that it is a subclass of the exception class. The argument type of the catch block exception type declares the type of exception that the handler can handle, and it must be the name of a class that inherits from the throwable class. So we saw in the hierarchy of our errors or exceptions that the exception class is inherited from the throwable class, and all of these classes, for example, are one way or another, or directly or indirectly, subclasses of the throwable class. So it must be a name of the class that is inherited from the throwable class. In other words, this exception handler class is a subclass of the exception class that was in turn a subclass of the throwable class. So our exception types must belong to one of these classes. The system considers it a match if the exception object can legally be assigned to the exception handler argument. It will try to match the error with this class or with the object that we are creating over here, and if they match, then appropriate message will be displayed. Otherwise we might get another error. This is the hierarchy that we can see. The object class is the superclass of all the classes in Java. Then we have a throwable class. The throwable class has a subclass exception. The exception class has another subclass, for example IO exception, and the runtime exception, which has the subclass arithmetic exception and array index out of bounds exception. The array index out of bounds exception is a subclass of the runtime exception. That it is in turn a subclass of the exception class, and that in turn is a subclass of the throwable class. So whatever we are creating an object over here to handle our exceptions, that must be a subclass of the throwable class. And also the system consider it as a match if the exception object can legally be assigned to the exception handler argument. So these will try to match. For example, if we are trying to handle an arithmetic exception with the array out of bounds exception, then the compiler might generate an error for this, or we might get a runtime error for that. So if we are not sure, we can use the general exception class. If we are sure about the kind of error that we might get, then we can use the specific exception handler class. By catching the exception, it allows the program to continue executing. As we saw previously, as we can see over here, that once the exception has been handled, the program executes to the next line. Now look, you can look at this example exercise and try to find the output for this code fragment. There is an array, then there is a code for trying to assign the length of that array to a number, and there is an exception handler. So you can try this code and try to find what output you will get.